Google Cloud has to offer. And now we're going to just kind of provide a brief description about what these services actually are. So firstly, cloud storage. You can sort of think of it as like Dropbox, but it's kind of cool because you can also use it to host static websites. So there's two types of websites, which is static and dynamic. Static websites don't really change. You can kind of think of it as like if you were to open, a restaurant or a local bakery and you just wanted a place to display your products, tell people your address, tell people your founding story, you just have these pages that don't really change of HTML and CSS code, right? So you can upload them into cloud storage. And if you actually provide an address to the location of that HTML file, it will display an actual website. So you could host static websites there. Cloud SQL is a database that's within the cloud, and it uses a lot of SQL forms, which is SQL is structured query language, and it's a language type that allows you to modify and work with SQL database types. So there's MySQL, SQ Server, etc. And yeah, so you have access to all of that in the cloud. Next slide, please. So next is the Google Kubernetes engine, also pronounced JKE, or not pronounced, but called JKE. And it just provides an environment for deploying, managing, and scaling your containerized applications. So what is a container? Containers are just lightweight virtual machines. We're going to expand more about what virtual machines are later on, but you can kind of think of it as like having a little computer within your computer. And Kubernetes is a service that deploys these containers. So it's essentially just creating small-scale operating systems that just exist to run code for your needs. And you don't really have to deal with like the more back-end stuff. You just kind of code and just run it like that in a vacuum. It also contains clusters, which are just defined as multiple virtual machines grouped together. So you can kind of think of it as having like a room full of computers that you can use for your server, but you don't actually have to maintain it, and you don't actually own that room or the computers. You're just kind of paying rent to them. And then we have BigQuery, which is just simply described as a data warehouse that can analyze data. Next slide, please. Then we have Cloud Functions. The easiest way to explain this that made sense to me was, I don't know if any of you guys have ever taken Professor Dominic Attanasio for C++. He used to do this thing where like he had a giant header file full of functions that he has written before but are like very reusable. So like, for example, like a function that reverses a string, a function that like I don't know, just things that you will use like over and over again, like input validation functions, whatever. And he just stores that in a header file. So it's like your include. And if you don't know what a header file is, you're basically just like, it's like you're storing your code on a different file and then injecting it in this page, but you don't actually have to see all the code that's contained in the header file. So he's just putting it there. And it's like the same thing for Cloud Functions, but instead of like your mega doc of C++ code, you're just storing it in the cloud. You don't have to hold it on your computer. So yeah, it's known for its serverless architecture, which means that you let Google Cloud handle the servers. Like, it's still running on a server, but you're not responsible for it. So code execution is handled by the cloud. And then we have Cloud Run. So what Cloud Run does is it takes a container of your pre-built app or like your application on it, and you deploy it also within a serverless environment. Okay, next slide. Okay, and then Google IAM. So if you're working on a big project, and you have like a team, you don't necessarily want everybody on the team to have access to everything. So what you can use this for is you can say, Amira, you're in charge of doing this portion, and Eric, you're in charge of doing this portion, and you guys are not allowed to see like the other stuff because that's distracting, it's clutter, and you might also have some like sensitive data that you don't want everybody to like just be in. So you can sort of delegate roles with that, create accounts for them so that they have limited access to certain things.
All right.
And then we have Google Cloud DNS. So what you can, so domain names are just website names. But if you guys have ever made a website from scratch before, you would know that like if you were to publish it on like GitHub, for example, the website name is like super ugly. It's like it just has a bunch of like random characters. It has your GitHub, it has your address, and it's not catchy, you know? Like we all remember how to find Google because it's just google.com. But like imagine if it was like EKW, like Google ZR, like it's like no one wants to read that, no one wants to remember that. So you're kind of just like yossifying the website names with domain names. So what you can do is you can register your website on Google Cloud DNS, and you're going to tell them, I want my website to be called this instead. So when a user tries to access like crystal.com, you know, it will shoot to the cloud, and then the cloud will redirect to the actual website name, which is like the ugly one. But your users don't ever have to memorize that. They don't ever have to see that website name. Okay.
All right.
And I think that pretty much sums up the big Google Cloud services. So now Amira can talk about Compute Engine.
Yeah. Just to make sure, if there's anything weird going on with the slides, don't worry about that. I think this is just a technical issue on my part. But anyways, Compute Engine. This is our main focus for today. All right. So what is it for, right? As you know, you've kind of seen the preview. It basically runs virtual machines, and that helps you host websites and servers using Google's infrastructure. Which what that means is that you don't actually host the virtual machine using your own computer. You'll learn about that in just the next slide, right? Okay, so what is a virtual machine? First off, it's pretty cool. So if you don't know what it is, get ready. Okay, so a virtual machine is basically a computer inside of a computer. What it is that you can be running your own, Windows, and then have like an operating system. So have this virtual machine, but it's in Mac. And you can also run Windows, you can also run Linux, you can run different operating systems, but that little virtual machine that you're running, it's not aware that it's inside a computer. It works exactly like a normal computer. And this is perfect. This is very advantageous if you want to test things, right? If you can break things, you can do things with low cost, right? Because if things break on that, virtual machine, you deleted something you weren't supposed to, it doesn't run as well. You just delete it and you start a new one. So there's also different things, right? If you run different types of, basically, to match your users' devices, right? They have different GPUs, different CPUs. Their RAM is different, so you can replicate the conditions that they have and check if whatever it is, like if they have problems with their specific, hardware, or with their specific, not just operating system, but also all the other stuff that adds up, right? Because you're replicating their environment. So there's kind of thing. Yeah. So for our, since we're using Google, again, we're using Google infrastructure, right? We're basically, it's better for us since they're using their own devices to run our virtual machine, so it doesn't put as much strain on us. All right.
Oh, I'd like to add that it's also a lot more cost effective and it's just less work in general. Because if you wanted to create this exact same situation, you would have to go out and like buy a computer like that, and that's so much more expensive. You'd have to maintain it. If it breaks, you're responsible for fixing it. But you're basically, for a lower cost, paying somebody else to just handle that themselves, you know?
Yeah, actually, that's a really good point. Thank you for adding that. Is that instead of going and buying a new computer, you just have one device. You don't have to buy another one, and you can run different, you know, as if you bought another device, all in one, in your own device.
May
Yeah,
I say something?
of course.
Fantastic. Yeah, so I can give an example, and I'm the guest speaker, by the way. My name's Rockford. Hello. So I can give an example of where this was relevant for my job. So I work on multiple services in my job. I work at UCSD as a DevOps engineer. So I just manage a bunch of servers and websites and services and so many things. But yeah, we have two big services. One of them's hosted in the cloud, the other's hosted locally. Whenever our local machines that has like 30 different computers in it, whenever like the big computer, the cluster that like oversees all of those goes down, oh God, someone has to like go to the campus at like 5 a.m. to like go fix it. I can't do that. I live in Los Angeles. I work for San Diego, but if our virtual servers go down, well, that's just as simple as going to Google Cloud, press the reset button. No one has to leave their home. It's nice. It's simple. It's easy. So that is a big benefit to having virtual machines. Just kind of like what Amir and Crystal were saying. Other people are managing the work for you in terms of the maintenance, and it makes things a lot smoother.
Yeah, thank you very much. So,
Problem.
as you can see, like there are a lot of advantages of virtual machines. So, moving on to the next slide. There are also many types of virtual machines, right? So, here's the thing. Um, can I have um Crystal help me out with this one?
Yeah, sure. Okay. So not all computers are built the same. Some are going to have a better processor, a better graphics card, whatever. But I know like our natural instinct is I want the best computer, but like, do you have best computer money? Like, probably not. So if you're going to use a virtual machine, they're going to give you a lot of different options for what you can choose from, like you're shopping for an actual computer. And obviously, the more impressive computers are going to cost a lot more money. But you can kind of pick and choose which strengths that you need the computer to have based on what your project is. So, like for data science, you're going to need a good graphics card. And then you also need to pick how beefy you need that computer to be based on things like, oh, is it static or dynamic? Because if it's static, your computer doesn't really need to be doing that much work, right? It's just displaying a page that doesn't really do much. It just sits there and looks pretty. But if it's dynamic, then there's some backend stuff going on. You're going to need something beefier. If your website is supporting a lot of people, then it's also going to need to be beefier. If it's a small business one, then why do you need like a super good computer to support like 5 people that go to your website like a week? You know? So yeah, these are the questions you're asking when you're choosing computers. And yeah, just consider that. Consider the needs versus the cost.
Yeah, thank you, Crystal. So, deploying a website using Compute Engine. But first, what is Linux? So, here's the thing about Linux, right? Why is it good to use it to run servers, right? So, Linux is pretty cool because what you can do, you can perform updates without rebooting or restarting. So, think about it that it's not obvious that you had to make an update or it doesn't disturb the server itself. And there are more advantages like how you can automate tasks, and just for programming in general it's easier. It's nice to use Linux because it makes you can do things. Well, what I'm trying to say, it takes less steps, right? It takes less steps to get to where you want to get to, or install things, or as it says, quick and efficient. Just know with provided that you have some coding knowledge. So
Okay.
yeah. Thank you.
Sorry, Amir. Okay, so we're going to be using Linux a little bit to deploy our website in the later part of the workshop. So you don't need a full out like Linux tutorial right now, but we're just going to be exploring the commands that we're probably going to be using in the workshop. So firstly, you're going to be running these on your computer's terminal. Now, I have a Mac, so I don't really know what you like Windows users go through, but like I'm assuming you also have a terminal. So the big commands we're going to be using are sudo, vim, and touch. And sudo, I like to describe it as like the big boy command, because like sudo is basically, you know, just walking into a room and being like, I'm the boss. Like you all have to listen to me now. You know, there are certain things or commands that your computer is going to block unless you use the sudo command with it. So what sudo actually does on a more technical level is granting you root privileges, and the root is basically the heart of your computer. So yeah, if your terminal is screaming at you and saying, oh, you can't do this, sudo it if you think it's safe, because like you might do something really bad if you don't like consider, you know, maybe I shouldn't be doing this in the first place. But like I think for touch and vim, your computer might yell at you for trying to create a new file, and that's obviously not going to screw something up, so you can use the sudo command with it. So touch and vim are very similar in what they do. Both of them at their core just kind of makes a new file. The only difference is that vim will only do it if the file doesn't already exist. So we can use it to create web pages in the terminal, which we're going to be doing later.
All right. So we're gonna get started. Introducing our guest speaker, Rockford Mankini.
Hello.
Hello, thank you.
Let's give it up for Amira and Crystal. They did a great job. You know, very exciting presentation. You know, there's a lot of important stuff that you can do with cloud infrastructure, and not just through Google, but you know, Amazon, Microsoft. They have services like this, but I think Google definitely has the best, and I think it's great that you guys are learning this. Some quick background on me: I'm a UCLA alum. I graduated with a bachelor's degree in statistics and geographic information systems. So basically, math and map making. Not super exciting. But I always wanted to be a programmer. And, you know, I got lucky. UCSD picked me up as a DevOps engineer, so I manage a lot of services for them. I've been doing that for the last 6 months, ever since I've graduated. Graduated all the way back in June, so not too long ago. But, you know, I do things like managing our machine learning platform. I manage a lot of the back end code that helps manage how everything works in Canvas for UCSD. It's a great job. I love it. I use cloud-based infrastructure all the time in my current job, so I'm really excited to share it with everyone. I also work as a full-stack engineer at B Capital Group, an investment firm. Before we get started, does anyone have any questions? All right, let's get to it then. So I'm going to share